Good morning, everyone. So yesterday we have talked about few topics regarding the neural network. Let's continue with the rest of those which were remaining. So yesterday we have seen this one. This entire part is called as convolutional base, which we discussed yesterday. Convolutional base consists of convolutional layers and ReLU activation function as well as pooling layers. So we will talk about the pooling layers in a bit. So let's move on what is present in the next slide. So the next that we have is pooling layer. So what did we discuss about? The output size. How can be the output size? For suppose if we have an image as input, which is of size 32 into 32 into 3. 3 indicates there are 3 different color channels. So 32 is, it is width, this is height, and this is depth. So 3 color channels is nothing but we have red, green, and blue. That is indicated by 3 here. Now what happens if I apply any filter or kernel which is of size 5 into 5 into 3, we will have additionally one bias also. So totally how many parameters we will have? That is 76 parameters. And if you apply such filter, like 10 filters, we will have totally 760 parameters. So if we have this filter size, this one, image size, this one, and how can you find out the output size? We have seen the formula output size is equals to the image size, the input size, minus the filter size, divided by stride, plus 1. So how many strides you are moving, whether 1, 2, 3, based on that, you will get the stride. That is nothing but the output size. The next one that we have is pooling layer. So what is pooling layer? Let's see. So if you have an input layer, which is 224 into 224 into 64 size, now what happens? We are doing the downsampling. So what do you mean by downsampling? Downsampling is you are reducing the size. Downsampling is nothing but you are reducing the size. So 224 into 224, after downsampling, it became 112 into 112. And this pooling layer or pooling is also a kind of downsampling. After applying the pooling, also the size gets reduced. So see here. So here 112 into 112. But for this image or the input, I'm doing the pooling. Again, the size gets reduced. That is 112 into 112 into 64. So we have 3 types over here. 3 types of pooling types. That is max, average, and L2. If you apply max pool on an image, if you see here, if you apply max pool on an image with 2x2 filter, then you pick the maximum value. So for this 2x2 filter, there is 2x2 filter. So this is the size of the filter based on input. So what is the maximum value in this one? That is 8. That will be your output. In this, what is your maximum value? That is 6. That will be your output. For this, what is the maximum value? 9. That is your output. And for this 2x2 image or size, what is the maximum value? 9. This is max pool. This is the pooling type. The first one, that is max pool. And in average, what happens? In average, it will take the average of these values like 7 plus 3 plus 8 plus 7 divided by 4. This will be your output in the first cell. Just like that, it will take the average of all the values of filter size 2 into 2. That is what happens in average. And when we go to L2, what happens in L2? You take all the values, you square them and take the square root of it. That will be your output value when you go for L2 type of pooling. So these are the 3 pooling types that you have. Ultimately, pooling is useful in order to reduce the size of your input or size of the output. So see, this is maximum pool and this is feature map. This is what happens. Okay, so this is the pooling layer introduction. And let's see what is there in the next slide. The next one that we have is pooling layer summary. So what is pooling layer summary? When you apply a pooling layer, there are no parameters that your model is going to learn. So here, it requires 3 hyperparameters. Let's see what is that. These are the hyperparameters. You can go through this one. So it accepts a volume of size that is width, height, and depth. And it produces a volume that is W2, H2, and D2. So how can we find this? We have talked about the formula of the output. What is the formula of the volume of output? That is N minus F divided by stride plus 1. So accordingly, he changed the formula. N is nothing but the first input volume or size, that is W1 minus F divided by stride plus 1. That is your formula, which we have already seen. And then this is height and this is depth. This is how we will find out. And it introduces 0 parameters since it computes a fixed function of input. So here what happens when you apply a pooling layer, there are no parameters that your model is going to learn. That is nothing but 0 parameters. Note that it is not common to use 0 padding for pooling layers. We will see what is padding in the coming session. So as we talked about padding yesterday, and the next one that we have is fully connected layer. So what is fully connected layer? So for this, we will supply image. So see, so we have an image. We have an image and we will supply this, or we will supply our image to the convolutional base. And what it happens, what this convolutional base will do, it will extract all the features. It will extract all the features. After extracting all the features, what we do, we supply this to the fully connected network. We supply this to the fully connected network. Fully connected network have multiple names you can go through. Now, after connecting it to the fully connected network, what we will get? We will get the probability of each and every class. Once we supply those features that we have extracted through the convolutional base, we will supply that to the fully converted network. We will get the probabilities of each and every class. And you choose the class that is having the highest probability. So this image is supplied ultimately to the fully connected network after extracting the features. Now, what is the probability? Which one is having the maximum probability? That is the image car. So we will choose the car as output. This is what you have in this picture. Fully connected network contains neurons that connect to the entire input volume as in ordinary neural networks. And then what is it? So here is an example given. So what is this example? If you see the initial convolutional layer, what it captures the edges. So this is an image. This is an image over here. Now I supply this to the first convolutional layer. So what is it identifying? This is the first convolutional layer. It is identifying the edges of the image or the input. And after when I supply this to second convolutional layer, what happens? It is difficult for us to understand what it is capturing. And again, when we move on, I can't understand anything. This is very blurred. So it is difficult for us to understand. And again, it is going to the next convolutional layer. And now, which one is having the highest probability will be your output. Out of all the numbers that we have, the most probability is present for 7. So 7 is my predicted value. And the confidence is 99.9999%. So this is just an example provided, which is fully connected network, which consists of convolutional layers. And all together is called as convolutional base. So this is an example here. This is an image. This is an image over here. This is 28 into 28. It will be supplied to the fully connected network and it will be identified based on the probability which is having the maximum. The next one that we have is a case study. There is a case study related to AlexNet. Let's see what is there. So here, they are experimenting. So you can see a lot of different values over here. So AlexNet architecture, the convolutional layer, the max pool, and normalization, and convolutional 2-layer max pool normalization. All these things are present. What they are doing, they are experimenting. We don't know how many convolutional layers should we have, how many pooling layers we should have. If you look at this visualization over here, if you look at the visualization over here, you will first have inputs. And you will pass them onto the hidden layer where you have integration as well as activation again. Same, finally, it will pass on through multiple layers and finally you will get the output. But we don't know exactly how many hidden layers or pooling layers we should have or how many convolutional we should have. We don't have any idea. So what we do, we keep on experimenting with multiple values. So what is it? These are the details you can go through. Data augmentation we have seen yesterday, and batch size we have seen in mini batch SGD, and SGD also we have seen stochastic gradient descent. Learning rate also we have discussed, and CNN also we are talking right now. So these are the things that you can go through. ReLU is an activation function which is giving you the good results when you work on images. So this is just a simple case study given to you. So this is what present in this particular module. This module is all about convolutional neural networks. We are talking about one of the black box technique, that is neural networks, in which you have again different types: artificial neural network, convolutional neural network, and also recurrent neural network. So we have seen up to convolutional neural network. Let's see the next one that we have, that is RNN. Let me open the slides for you. The next one that we have is recurrent neural network. So what is it? As I talked about before, we have different types of neural networks. So one is artificial neural network. We can also call it as multi-layered perceptron or dense network. Any name is fine. So we have discussed about this. This is used to handle tabular data. This is used to handle tabular data or columnar data. And then we have the second one, that is convolutional neural network. This is used to handle videos. Videos is nothing but combination of images. And the next one we have is RNN. So RNN is used to deal with textual data. Whenever you have data which has sequence like time series and all, you can go for RNN. That is recurrent neural network. So these are the different types of neural networks that you have, which is specified for individual purpose. Let's move on to the agenda, what we have. Okay, so directly we have sequences are everywhere as heading. So what is present in this? So foreign minister, there are a lot of sequence of words present here. So after foreign, what we should get, the next word, you will get minister. And if you have speech, whenever you hear or whenever you have any sound, your speech also have separate or very words, like a sequence of words. So all those can be identified with the help of this. And if you have words and if you want to convert that into English language, see here, there are few words which are in different language. I want to convert them into English language. So, but the sequence may differ. What do you mean by sequences differ? So see here, the first word of German language becomes the second word. And the third word becomes the first word. And fourth word becomes the third word, and so on. So when we are converting one language into another language, the sequence of words may differ. That is one thing that you have to remember. The sequence in which we have words in one language might be different in different sequence in another language. This is also called as language translation. This is also called as language translation or machine translation. Or machine translation. Okay, translating one language into another language, but the sequences may differ. So this is what we have. And the next thing that we have is, so these are the things that you can go through the topics. And then we have the language models. So what is language models? We have a lot of language models to deal with textual data. We have a lot of language models to deal with textual data. In what scenario they are going to be useful? They will be useful in terms of the first one that we have is next word prediction. The first one that we have is next word prediction. So if you have words like this, what is the next word after this one? We have to identify. So stocks plunged this morning despite a cut in interest rates by the Federal Reserve as well. What is the next word? I have to predict, for which I can use the language models. And also for spell checkers. What do you mean by spell checkers? If you see here, the spelling of this is wrong. The word is wrong. For that also, I can go for language models. And the next one that we have is mobile autocorrect. What is mobile autocorrect? When you are typing in your WhatsApp or something like that, there will be autocorrect, right? For that also, I can go for language models. And for recognizing the speech, for speech recognition, also I can go for this. If your speech is not clear, for suppose if your words or alphabets that you're spelling is not clear, it is incorrect, automatically it will be corrected with the help of language models. And also automated essay grading. What is automated essay grading? So here, when you type an essay, it will be automatically graded. That is nothing but using language models. And also we have talked about machine translation or language translation before. When you have word ordering, the probability that the cat is small or probability small the cat is, both of the words, when we check the probability order is more for this one. And for word choice, so walking home after school, walking house after school, which one is having more probability? Which word is having more probability? So the word choice may be home. The probability is more for this compared with house. For all these things, we can go for language models. We have a lot of different language models present to deal with the textual data. And what is the purpose of everything? We can go for next word prediction. We can go for spell checkers and for mobile autocorrect, for speech recognition, for automated essay grading, as well as for machine translation. For all these purposes, we can go for language models. This is about the simple intro of language models. The next one that we have is traditional language models. So when you look at the traditional language models, you have unigram, you have bigram, and you have trigram. All those things, if you have an unigram word cloud, and if you are talking about typical English dictionary, you already know about English dictionary, right? So English dictionary, you may have around 1,000 or 172,000 words. 172,000 words, approximately. Unique words are there. So unigram means, unigram, bigram, all these are present in traditional language models. Unigram means you have these number of words, which is denoted by B. And bigram means you have around V square words. Approximately, you have around V square words. In trigram, you look at the probability, or sorry, in bigram, you look at the probability of W2 occurring given that W1, which is word 1. So in bigram, you will look at the probability of word 2 occurring given that we have already word 1. In trigram, as it is indicating, you may have approximately V cube number of words. And if you have n grams in traditional language models, you may have V power n approximate number of words. So beyond trigram, we cannot work. Only up to trigram, either unigram, bigram, or trigram. So this is what you have, the formulas you can remember. And what is next? So these are the theoretical parts that you have. So you can, we have already discussed about this one. What we have discussed about before. Okay, so we have discussed before in 2013, people experimented with a lot of space or memory. For suppose, imagine they experimented with 140 GB of RAM for 2.8 days. It is present in some slide. Maybe we will see that. 2.8 days. 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 here. So here, if you see, in 2013, people experimented with 140 GB of RAM for 2.8 days. Like why? To build 126 billion tokens. So one challenge regarding the traditional language models is that beyond trigram, if you want to work, the memory that you need, the compute, the parameters that you need will be extremely high. So as we talked before, if we have n grams, you will have b power n words. That is very large. So you may require a lot of space or a lot of memory, and you need a lot of compute. You need extremely high parameters. All this is required. That is why we are telling like there is a challenge present in traditional language models. That is what we can't work beyond trigram. The previous words and what is the next one that we have? See here. So here, if you observe this example, so the previous words are not stored in the memory. The first one is this one, we need a lot of compute or memory. The second one is the previous words will not be stored in the memory. The previous words are not stored in the memory. That means what? We have memory for context issue. We have memory for context issue. So for suppose, if there is a lot of paragraphs present in a sheet, in the first paragraph, it was mentioned about history of Spain and France. Here you can see the example. So in the first paragraph, they have mentioned about the history of Spain and France. Now, then somewhere else, maybe in the fourth or fifth paragraph, they mentioned this point. The two countries went on a battle. This is mentioned in the middle of the paragraphs. So only if this particular paragraph in the memory, if it is stored in the memory, then only your model can understand or correlate with the word two countries. But in traditional language models, you don't have scope to store these in memories. So there is an issue called as memory for context. So the context is lost. Then came in another one, which is original neural language. We'll talk about it in a bit. So what are the issues present in a traditional language model? The first one is we need a lot of we need a lot of memory, we need a lot of compute, we need very high parameters if I want to work beyond trigram. And the second issue is the previous words are not having any scope to get stored in the memory. So we are losing the data. So we can't identify the correlation between two different words present in different paragraphs. So there is an issue called as memory for context. So these are the two challenges that we have in a traditional language model. So let's move on. So you can see the next one, that is state. So this is an example given. So our input is given to this RNN and it will give you the output. RNN stands for recurrent neural network, and recurrent neural network will be used to handle textual data, and convolutional neural network is used to handle videos or images. Artificial neural network is used to handle tabular data or columnar data. So you have parts, robot, so broken phone, all these are examples, okay? These are all the examples you can go through. The next one that we have is original neural language model using MLPs, that is multi-layered perceptron. Suppose in your data set, you have three words. Suppose in your data set, you have three words. And now you want to predict the fourth word. You want to predict the fourth word. So imagine this is the first word, this is the second word, and this is the third word. After these three words, what is the fourth word I want to predict? So in my data set, I have four words, W1, W2, W3, and W4, out of which three are inputs which I already have, and one is the output variable, x1, x2, x3, and this is my output. This I want to predict. Now, you want to predict what will be the fourth word. You cannot use your words as it is to your algorithm. You need to convert the words into numbers. You can't directly give them to your algorithm. You need to convert that into numbers. How can you convert that into numbers? How to convert these now into numbers and supply? For word W1, we need to convert into a number. Suppose you are using one hot encoding. We already talked about these when we are talking about the data preparation and all. So for suppose I am about to do one hot encoding. What happens in one hot encoding? You will take all 1,000 or 172,000 words. All these words are there, 172K thousand words. Now, wherever your word is present, that will be one and rest are all zeros. Rest are all zeros. This will be supplied, and then the second word is also having the same. So the size of everything would be V. The size of everything would be V. And you connect that to a hidden layer. Now you connect that to a hidden layer. If you have 3 neurons in your input layer and 2 neurons in your hidden layer, how many connections you will have? You will have VH connections, or we can say NVH neurons. If you have 3 neurons in your input layer and 2 neurons in your hidden layer, this is V, this is H, imagine. Now, how many connections will you have? How many connections? That is 3 2s are 6. That is N power or NVH neurons. And the output layer size would be again V. For every word, you will get the probability as output. As we talked about before, you will get the probability. And you will choose the word which is having the highest probability, which will be your output. If you want to calculate the size, it would be how much is the size? That is VH. VH is the size. So the vocabulary size would be, what did we find first? That is NVH plus VH. If I take VH as a common, that is N plus 1. This is smaller when compared with V power N. We talked about before in traditional language models, we have an issue of V power N when we are going beyond trigram. So this issue was resolved using what? Using original neural language. This was fine. Then what about the second challenge? We have the second challenge, that is memory for context. We have the second issue, that is memory for context. What is that issue? How can I resolve this issue using original neural language? So here, the number of parameters got reduced. So this problem of V power N words is gone. But now we have the context problem. If you have 3 words, and if you want to predict the 4th word, this will work. The algorithm that you design will work. But if you have different requirement, like if you have 2 words and you want to predict the 3rd word, this won't work because this is not the same data set. This data set is designed separately. So these are the problems that we have by using multi-layered perceptron. So people done a thorough research and they came up with something called as RNN, recurrent neural network. So we will see RNN right now. So this is the example here. The next one that we have is RNN, that is recurrent neural network. So what is there in recurrent neural network? RNN tie the weights at each time step. If you have a network like this, see here. If you have a network like this, you would have a hidden layer. And you are going to have 4 neurons. So for suppose, imagine you have a hidden layer here. And you have 4 neurons. You have 4 neurons. I am calling this as a dummy hidden layer. This is a dummy hidden layer. Just to have some symmetry, I'm adding this one. So why this is dummy? Because I've added all zeros. Now, if I have 3 words, I'm about to predict the 4th word, then every word would be converted into numbers. Every word needs to be converted into numbers. So what? We will do one hot encoding, which we have discussed before. In order to convert it into numbers, I will perform one hot encoding here. So the size of the first word would be V. So this is W1, this is W2, this is W3. And what is the size of this one? This is V again, and this is V again. The size of each one would be V. The size of the first one is V, second word is V, third word is V, and so on. And what else? What else? The number of parameters that we have will be VH. The number of parameters that we have will be VH for all the three words. Will be VH, VH, and VH. Now, you're going to get the output, which is of size V. I will get an output. This output size is V again. This is output. For each and every word, we will get the probability. And the word with the highest probability will be chosen as your output. After you come forward, as a part of your forward pass, you are going to calculate the loss function or cost function. We already talked about this before in neural networks. So when we are going to the forward pass, we will calculate the loss function or cost function. And then you go back and perform the back propagation algorithm. Why? In order to update the weights. Why we have to update the weights? In order to minimize the loss. That is our main objective, to minimize the loss or cost. Then when you update, you will have again different weights. You will have different weights. If you have n words, then what will be the weight? If you have n words, you will have n into VH weights. N into VH weights. So what is the weight of this one? See here. Here, for this is H. So H, this is H, this is H, and this is H, hidden layer. And this is H, this is also hidden layer. This is also H, this is also H. So this is what we have. And then what we are finding. So if you have words, n words, then how can I find the weight? So for n words, what is the weight for these? N into VH. And for these, if I have n, what is the weight? N into HH. And the last one that we have is this one, which is VH. If you take VH as common, what we will get? What we will get? This is n again, n plus 1 into VH plus NHH. This is what we will get. In a multi-layered perceptron, you only have n plus 1 into VH, which we have seen before. In multi-layered perceptron, we have n plus 1 into VH, but here we have n plus 1 into VH plus n into HH. Here the number of parameters got increased. The number of parameters got increased. That should not be the case, right? If you are coming up with an improvised algorithm, then what you should have, you cannot have more parameters than the previous one. So what happens here is, all the weights that we have, we will take the average of it. Here, what we will do in this improvised method is, all the weights that we have, we will take average of these weights. We will take the average, and then what? And then what happens? When we take average, when we replace all the weights with average, if n becomes 1, we will have 2VH plus H. This would be extremely less number of hyperparameters compared to the multi-layered perceptron. And another thing is storing the words in the context, which we have another challenge regarding the traditional language models. So another thing is storing the words. This word will go into this and it would save here. This word will go into this and it will save here. And then what? And then it will send the rest of the words, or the second word, it will move along and you will get the second word, it is supplied, and the second word is stored again, and then you have the third word, and third word is passed again and it will get stored, and finally you will get an output. That means the previous word's information is storing and passing along to give the output. So again, we have also solved the second challenge that we have in traditional language models. One is, we have extremely high number of parameters is required, which we reduced by using the average. And the second one is storing the context. Here it is storing the context in recurrent neural network. So both of the challenges have been solved with the help of an improvised technique called as recurrent neural network. And then what? If you have two words and you want to predict the third word, the network that you have is going to collapse. For suppose you have only two words, so these are not required. I will remove this one. So only two are there. I will get output. If you have more number of words, if I have 5 words, then it will expand. So according to your inputs, this will change. That problem also got resolved because we told before, if we design a data set for a problem like I have 3 words, according to this, I want to predict the 4th word. I can't apply the same thing on another problem like I have 2 words, I want to predict the 3rd one because both are different. But here in recurrent neural network, what happens? According to the inputs, it gets collapsed or it gets expanded. If you have less number of inputs than your current one, it will collapse. If you have more number of inputs than the current one, it will expand. This is about the recurrent neural network, the most important one, which deals with the textual data. So let's see what is present next. So these are called as recurrent because they perform same task for every element of a sequence. Only thing that differs is the input at each time step. Output is dependent. This can be seen as NN having memory about what has been calculated so far, which is storing the process. That is what we have about the introduction for recurrent neural network. The next one we have is RNN language model. What is RNN language model? So you can see the symbol here. The symbol here, this one, refers to the recurrent. It refers to recurrent. Here you have a word, you have a hidden layer. First hidden layer is always dummy hidden layer. I will take a dummy hidden layer here. So what happens here? Weights will be WHX. So I will take this one as H. This is input X. First, suppose imagine I have an input which is X and I am supplying this to the hidden layer which is H. Now, what is this weight? That is WHX. The weight is WHX. If we supply these to the more hidden layers and finally we will get the output, that is WHX into XT. So you know all about these things which we have. So we have this one. At the current time period, the time is T. But when we move below or beside or behind, it will be T minus 1, which we have seen yesterday. So at the current time period T, we have WHX weight, then this is going to be HT. And the previous one is going to be HT minus 1. So the weight will be W into HH into HT minus 1 plus W into HX into X into T. And you have an activation component sigmoid. You have an activation component sigmoid and you will get the output. Then in the final layer, when you have multiple words, you will use softmax activation function. What is the probability? That is the next word. The maximum probability will be your next word. So it belongs to one of the vocabulary words, which is given that you have a series of words. So this is the formula. You're applying sigmoid activation function. At the final layer, you will apply softmax activation function. So this is just the pictorial representation given to you. That is RNN language models. The next one that we have is recurrent neural network unfolds into a DNN over time. So this is the same representation in different way. So here you have a word, you have a hidden layer and so on. Here training happens based on back propagation through time. So T minus 1, T minus 2, T minus 3, this happens through the back propagation through time. If you have too many recurrent networks or recurrent units, then what will all the units are? These are all less than 1. Then it is going to come up with very small numbers. What if all the units are higher? It will be bigger value. It will explode. It will be like you will get an exploding gradient. Hence, people came up with BPTT. Hence, people came up with BPTT. You can go through this. This is a representation in another format. X is the input, H is the memory at time period T, and Y is the output. This is what we have. This is back propagation through time, which I have told you. So this is the formula. You can go through these formulas over here. So people come up with the next concept, that is back propagation through time. Why? As I told before, if all the units are having less than 1 value, it will be very less. If it is more than 1, if it is very large, you will get larger value. You will have an exploding gradient. So for that, people came up with a truncated back propagation through time. The downside is that you're stopping it somewhere. So all the patterns are not learned. You're stopping this algorithm somewhere. So you're not learning all the patterns present in your data. That is one challenge or one issue present for back propagation through time. So these are all the things that you can go through. Truncated BPTT, it is approximation, or that is referred to as for long sequences. The downside is that the gradient can only flow back so far due to the truncation. So the network can't learn all the dependencies. This is what the challenge that we have. The next one is recurrent network offers a lot of flexibility. So what is this one? Recurrent network offers a lot of flexibility. So you have vanilla neural network, you have image captioning, so all those things are present. So this is one-to-one. Vanilla neural network you have, which is one-to-one. One-to-one means what? You take one word and you predict another word. Just like that, you have this one. One word is there. Based on that, you're predicting another word. That is vanilla neural network. And again, you have image captioning. See here. The next one, you have image captioning. So you have an image and you use convolutional neural network because that is dealing with images. Why? To extract the features, and you supply that to RNN, which is recurrent neural network, and RNN will give you a caption to the image. That is image captioning. One to many. One image is there, many captions you can get. One to many. Then you have the next one, that is sentiment classification. Sentiment classification is many to one. You have multiple words as input and output will be only one. That is sentiment classification. The next one that we have is machine translation, which we have seen before. That is also many to many. It is also called as language translation. Translating the words in one language into the words in another language, but the sequence may be different. And the last one is video classification. You take each frame of the video and then you immediately give the mean to that, which is also many to many. So these are the various things present: vanilla neural networks, image captioning, sentiment classification, and also the next one that we have is machine translation and video classification. The next one is CNN plus RNN for image captioning. So if you have images and you want to supply it to RNN, you supply first it to CNN. Image is there, you're supplying it to CNN. After, what happens in CNN? In CNN, it will extract all the features and then it will pass on to RNN. You have unique identifiers like start and end in order to talk about the process. So start gave the word straw. Straw will be the input for the next one. And it gave the word hat. Hat is the input for the next one. And I've ended the process. Out of these two, which is having the highest probability? Hat. So your output will be hat. This is what, or it will give you an image captioning. Based on that, based on your requirement, you can use the CNN plus RNN together. Now what else? We have the next one, image captioning. See here. So the same one. Is there a data set to learn this thing? So there is a data set called Microsoft Coco. This one is the data set. You have a data set called as Microsoft Coco, which can be used, and this data set is having 120,000 images approximately. And for each image, you have 5 sentences. You can train your model on this kind of data set. You can train your model on this kind of data set. That is the data set Microsoft Coco. And these are the images. Man in black shirt is playing guitar. The captions of the images. And the next one is bidirectional RNNs. For example, having said that, it is done with training. So here see, it is done with training. When your algorithm is processing a word from left to right. So here, if you have a word, maybe she is done with the session. She's done with the session. So Kirti ended it. So this is the word that you have for suppose. Imagine. So here we are going from left to right basically. So here there is a pronoun she and there is a name here. So how can we correlate these two things together? We can't do it. Until it didn't find any word to correlate, we have a concept called as bidirectional RNNs. As it is treating this as another one and this as another one. When you process your text in both the ways, the problem will be solved. These two will be correlated. But the problem here is that the weights will become doubled. When we back propagate or do this for 2 times, the weights will be increased. The weights will be increased. That is the thing present for bidirectional RNNs. Problem for classification, you want to incorporate information from words, both preceding and following. Because it is adding a lot of weights. That is what we have. To maintain 2 hidden layers at the same time or at any time, this consumes twice as much memory for its weight as well as for parameters. For that, again, you have the next one, that is deep bidirectional RNNs. So here, we also have the next one. This is bidirectional, but instead of having one hidden layer, we will have multiple hidden layers. We will have multiple hidden layers. So the number of weights are also going to increase here. So at time step t, each intermediate neuron receives one set of parameters from the previous one and two sets of parameters from the previous one and so on. It will also increase the weights. This is another one present, which is deep bidirectional RNNs. This is what we have pertaining to RNN. RNN stands for recurrent neural network. So RNN means, what is the purpose of this one? What did we discuss till now? So till now we have discussed about one of the black box technique, that is neural networks. So coming to the neural networks, as I talked about before, there is artificial neural network, there is convolutional neural network, and there is recurrent neural network. So this is used to handle tabular data or columnar data. This is used to handle videos. Videos is nothing but a group of images. And RNN is used to deal with textual data. And we have seen all the things like what is starting from the base, why we are doing this, what are the weights, what do you mean by input layer, what do you mean by hidden layer, what is back propagation useful for, what is loss function, what is cost function, all these things we have seen. RNN is useful for textual data, to handle textual data. So if you want to perform CNN plus RNN also you can do. So you can take the image, first supply it to CNN, get the features and supply it to RNN. This is also how we can perform. Let's see how to work on this using RapidMiner Studio. Let's see how to work on this using RapidMiner Studio. Let me go back for you. This is what we have. You can just go through these things. Let me open RapidMiner Studio for you. Just give it a second. Okay, now let's check out how to work on neural network in RapidMiner Studio. So up to now, we have discussed a lot of things, supervised, unsupervised. supervised algorithms, how to work on this tool. We have seen a lot of those. You have to remember those things also. So for now, we will work on neural network. First, we have to get our data. So how to import our data? I will use read Excel operator because I don't want to store it in my repository. I just want to import my data here through the operator. So my file that I'm going to work on with is an Excel file. So I'm using the operator read Excel. So this is the operator that I have. And I'm going to import the data set that I have named it as K-cross validation. So you can use any data set that you want. So I'm just using this particular data set, which is present in my documents. And I will check out whether the formatting is present perfectly or not. I don't have any problem. So I'll click on finish. Now I got my data set. Let me show you the data set first. First, connect to the response port and execute the process. Once you execute the process, you will directly go to the results view where you can check out how many rows and how many columns are there in your data set and what are those columns. So I have different columns present, totally 106 records and 5 columns are there. Okay, these are the columns and these are the records that you have. And then now I am going to predict the heart disease based on cholesterol. You can check whatever you want. So see what I'm doing. I will use the next operator, that is select attributes. I am selecting the next one, that is select attributes. Now what to do? So here select attributes is there. So click on it and I want to select only few. So I'm selecting subset here, and in the parameters, why parameters are used? In order to customize your operators. In order to do the customizations of your operators, you have a special component called as parameters. So I want this one and this one. These 2 columns are enough for me. Now, I want to set a role. Why? Because this is where I have to tell which one is the output variable which I want to predict. So all these things I have to set with the help of the operator, what? Set role operator. So take the set role operator and I want to set the column which is heart disease as the output variable or label variable. So double click on this operator, or you can just click on this parameter also. Anything is fine. Now I'm going to choose the column that is heart disease and I'm going to set the role as label. This is the output variable and click on apply. Click on apply. Now what? I will do the validation using different types, in which I will show you the new one, which is split validation. In which I will show you the new one, which is split validation. Split validation is an operator. If you want to see the description of this operator, what you should do? Right click, F1, and see the description over here. This performs a simple validation by splitting the data set or the example set into training and testing and evaluates the model. Okay, this is what we have. And how to get to the training and testing, 2 different modules. Just simply double click on this operator. Now we will get to the training and testing. And here in the training phase, you have to apply the model. So what is the model that we are discussing about? That is neural network. So take the neural network operator into the process. And then I have to apply the model over here. So I'm taking apply model here. And also the next one is performance classification in order to check the performance. I'm taking this also here. And now you can simply click on this plugins if you want to make the connections. See? And whatever that are missing, you can just match it them. So this is what I have. If you want to rename this, you can rename this. So I will just connect the mod to mod. So make sure you are making the connections properly. If you want to just rename this one, you can rename it. If you don't want to rename it, is also fine. For now, what I do is I'll copy these 2 operators, Control C. I'll go over to this testing phase and I will paste here. Control V and establish the connections again. From here to here, from here to here. And also for the performance, also check here. These are the connections that I have. And what else? What else? What else you have? Do you have to check any parameters? Do you have to rename any parameters? Do you have to rename anything? You can do anything you want. So what I do is I will just rename this as performance for training. This is training data set, right? I will name it as performance for training. And here also, right click and rename. V for testing or test, anything is fine. Now the connections are fine. If you want to go back to the process, just simply click on the process here in the blue color. Now I will just check it here. The parameter of validation as stratified sampling, anything is fine. Now make the connections properly. I don't want training, so I'm making connections like this. Now this is fine. Execute the process. Now check out the performance for test and performance for training. And this is the neural network. This is how it is looking like. You have one input, one hidden and output. If you want to make changes, what you do, you have to go to the parameters of neural network and change it here. If you want the learning rate to be 0.2, and you can make this cycles as 100, and you can check the accuracy. Everything is experiment here. This is 87% accuracy here and 79%. So you can check the accuracy by making different experiments and you can deal with this. This is neural network. If you want to replace this with some other thing, so see here, I'm right clicking here, replace the operator with modeling in which predictive is there. You have a lot of different types. You can go through all these things. So predictive, I have neural networks in which I can go for perceptron, I can go for deep learning, I can go for multi-layered perceptron also. You can check multiple things from here itself. Just I'm changing the operator from neural network to auto MLP. MLP stands for multi-layered perceptron, and you can check the accuracy. It is way better when compared with the previous one. And you can check for deep learning also. Replace the operator. You can go here, which is modeling, and we can go to predicting, and the neural network, that is perceptron. If you have input, output, and hidden layers, that is called as multi-layered perceptron. If you don't have hidden layers, that is called as perceptron. So check the accuracy, it is very less. So this is not good. So perceptron, replace again, that is modeling and predictive and neural network and deep learning, and execute the process. Now check the accuracy. This deep learning and auto MLP are giving you the good results. This is how you can perform neural networks. What did I do? Let me explain you one more time. So first I have just selected my data, which is an Excel file. So I have used the operator read Excel. And the second thing that I've done is I have chosen my data or data columns, whatever that are required for my analysis process. By using which operator? That is select attributes operator. And I have set the role, which is the column heart disease as an output variable or label using set role operator. And I have split my data using which operator? That is split validation operator. After that, I've got training and testing, in which I applied multiple algorithms to check which is giving me the better results. And it is, one is deep learning and second one is auto MLP. And you can keep on experimenting by changing the values in your parameters also. And I have taken here p-value and here also p-value because I want performance for both training data set as well as the testing data set. I've got the performance and I've renamed this operator as P for training and I renamed this operator as P for test. And again, I replaced the first one I've taken as neural network. Then I replaced it with auto MLP, that is multi-layered perceptron. And I have also replaced it with perceptron. And last I have taken deep learning. Out of the 4 algorithms that we have worked, I have got good results with auto MLP and deep learning. So you will ultimately choose the algorithm depending upon the accuracy itself, right? So you can experiment like this and get the accuracy. Okay, this is what we have regarding neural network. Let's have a quick 10-minute break and we will have a quick recap of whatever we have learned from the start onwards. So the deployment of model, all these things that can be done with the paid version, or you can do it with auto model, but currently this is not working for me. So auto model is where I have shown you in the first session. You can just experiment regarding some data depending upon your requirement on different algorithms and which is giving you the best performance or best results. That can be shown with the help of auto model. So let's have a quick 10-minute break and we will just talk about everything that we have discussed from the start of our session. So I'll be on mute.
Depois disso,
Okay, everybody, let's continue with the session. So we are done with a lot of topics right now, like up to now. So let's talk about or have a quick recap of whatever we have discussed from the first onwards. Okay, we will talk about the operators because we are mostly concentrating on this tool. So here, first, let me open the mind map and then we will start discussing about this. So we are using a methodology called as CRISP MLQ methodology. So you have a lot of different steps, out of which what we have discussed, first step that we have is business understanding. So what do you do in business understanding? In here, you will just understand the objective of your project or your business objective, we can call it as. First of all, the first step is to understand your business problem. You have to understand your business problem. Then you have to understand your business objective. And also you have to understand your business constraint and also the success criteria. So you have business success criteria, ML success criteria, and also economic success criteria, depending upon the project. And what else? When you are talking about the objective and constraint, these have to be mentioned within 2 to 3 words. Like minimize the profit or minimize the inventory or minimize or maximize the profit. All those things needs to be mentioned in 2 to 3 words. And always you have to use two data optimization terms. One is minimize, second one is maximize. Mostly you have to use this. This is what we have under the first one, that is business understanding. Once you are done with all these things, you have to go to the next one, that is data understanding. Coming to the data understanding, we have seen there are two things that are present under this. The first one is you have to do the data collection. Whether you are collecting the data from the primary data sources or the secondary data sources, you have to understand. And also you have to understand the data types of your data. All the columns data types you have to get a knowledge about under this data understanding section. And coming to the third one, the most important one, which is data preparation. The third one that we have is data preparation. And in data preparation, again, you have EDA. EDA stands for exploratory data analysis. EDA stands for exploratory data analysis. And the next one that we have under the data preparation is data pre-processing. Data pre-processing. So coming to the EDA, you have 4 business moments. What are the 4 business moments? The 4 business moments are the first business moment, that is measures of central tendency. Measures of central tendency. It consists of mean, median, and mode. And you have the second business moment, which is measures of dispersion. Which is measures of dispersion. And measures of dispersion consist of standard deviation, variance, and also range. And the third business moment that you have is skewness. Skewness talks about the asymmetry of your distribution. If the skewness value is 0, then your data is normally distributed. If it is greater than 1 or less than 1, then your data is not normal. And the fourth business moment that you have is kurtosis. Kurtosis talks about peakedness of a distribution. So, kurtosis value, if it is equal to 3, then that is said to be a normally distributed data. If it is greater than 3 or less than 3, then that is not normal. Then how can you perform all these things in RapidMiner Studio? Let's see. Let's see how to perform all these things in RapidMiner Studio. So let me go back. So I'm just deleting this process, whatever we have created, or I will go for the new one. Anything is fine. So I will just delete all these things. Now I'm going to use sample superstore. Maybe I have just saved it in our local repository, I guess. I don't know exactly. If not, I will use the operator. So this, I have sample superstore. See, I'm just using this in order to show you how to just perform all those business moments here in your studio using an operator. And before going to that, we will talk about the components present in this particular RapidMiner Studio. So there are 4 or 5 or 6 more components present in this interface. The first one is repository component. It is useful to store your data as well as your process. And also you can import your data also with the help of repository component. The second component is operators. You have inbuilt operators present in this particular RapidMiner Studio tool, which are useful for performing all the types of operations, which we are doing in Python or any programming language using code. But here this is called as a no-code development platform for data mining. This particular platform is called as no-code development platform for data mining. Why? Because here I am not writing any single line of code, but still I can perform all the data mining tasks like association, estimation, forecasting, clustering. All these things I can perform just using drag and drop interface. That is why it is called as no-code development platform for data mining. And coming to the next section, you have parameters over here on the right side. This component is useful in order to customize your operators. And then you have the process. Process is where you will create everything. You will create a workflow. And design view, there are views are also present. Design view is useful to connect one operator with other and execute the process. Everything up view. Coming to the second one, you have results view. So results view is where you will get the results of your executed process, and also you will see visualization and statistics of every column under this results view. And turbo prep is specifically used for cleaning your data, and auto model for building your models. These are the various views present, and this is the interface of your RapidMiner Studio tool, which we installed in our sessions. So here what I'm doing, I want to show you the ADA, how to do it here. So for this, I will simply use the operator extract aggregates. You have to remember the operator, what you have to use for which purpose. If you understand the theory, if you understand the operator, it is very easy for you to do everything here. So take this operator here, make the connections, do not miss out the connections. After making proper connections, execute the process. And here in the parameters, you can check out what are the values that you want. By default, I'm taking everything. So here, if you see, I got sum, mean, first quartile, median, mean I got, median I got, minimum I got, maximum I got, standard deviation I got, skewness I got, kurtosis I got. And how about mode? Mode I can calculate for categorical columns. So I have a separate for that, separate operator for that, that is extract mode. This is one more operator to calculate the mode. This is how you can perform the explanatory data analysis in RapidMiner Studio. And then what else you have? The next thing that we have is data pre-processing. So data pre-processing, again, you have a lot of different things. Like what? Like you have missing values, you have cleaning your data, you have a lot of different things. Let me tell you which is the operator that we are going to use and what are the different things present. First one that you have is under data pre-processing. Under data pre-processing, we have organizing our data, which is nothing but unformatted data is that you are organizing it into a proper format or a tabular format. Okay, and then you have the next one, that is typecasting. Typecasting is nothing but changing one data type to another data type depending upon your purpose. So which operator you will use in RapidMiner Studio for typecasting? So there are a lot of different operators, like what? Like numeric to binomial, or numeric to text, or numeric to date. There are a lot of different operators for which you can use it for typecasting. And the next thing that you have is handling the duplicates. The next thing that you have is handling the duplicates. So what you have to do in order to handle the duplicates, which operator? The operator that you have to handle the duplicates is remove duplicates. The operator that you have to handle the duplicates in RapidMiner Studio is remove duplicates. And then again, you have the next thing that is outlier detection. You have detect outliers operator in RapidMiner Studio in order to detect your outliers. And the next thing that you have is missing values, or you have discretization. Discretization is nothing but converting categorical into numerical, which you have the operators like this. You also have discretize operator directly. And the next thing that you have is encoding. Encoding stands for, or encoding is useful to convert encoding is useful to convert categorical into numerical. Discretization is used to convert numerical into categorical. For these, you have a lot of different operators present. And the next one that we have is missing values treatment, and also standardization, normalization, like you have scaling techniques for which you have standardization, normalization, and dropper scaling. For these, you have a single operator, that is normalize operator. For missing values, you have different types of operators like replace missing values, impute missing values. These are the various things present regarding the cleaning your data, and these are the operators that you have in your RapidMiner Studio in order to work on these particular operations. Okay, we are done with business understanding, we are done with data understanding, and we have also discussed about data preparation. Then what about the next ones? What are the rest of the things present? Before talking about the model building and all, I want you to show one more operator, that is K-cross validation. In RapidMiner Studio, you have one more operator, that is K-cross validation. So let me go back here. Let me delete the process over here. And I want to use again the Excel file, K-cross validation data. So read Excel operator. And I'm importing my data, that is K-cross validation here. This is the data set that I want to show you. And here, I'm just taking this as next, finish. Okay, now I got my data set. Now, for this one, I want to set the output variable by using which operator? Set role operator. Take the set role operator, make the connection, and change it here, which is my output variable is hard disk. That needs to be labeled and apply. Now everything is good. Now I want to show or use the operator K-cross validation. So see, what is the purpose of this operator? If you want to know, you have to go for F1 and description. So this operator performs a cross validation to estimate the statistical performance of a model. So take this into the process, make the connection, and it will also split the data into training and testing. So double click on this, you will get training and testing. So what I do is I will apply one simple algorithm, that is deep learning. I will take the deep learning into the process, into the training phase, and apply model over here and performance classification over here. Establish the connections properly and execute the process. So I don't want this wait, I want example here. Example and test. Okay, this is so fine. And this I need to be clicking here. And you do that for validation also, cross validation. Make sure every connection is connected with each other, every operator is connected with each other, and execute the process. It is taking some time. This is your accuracy, which is 88%. So this is how you can use cross validation also in order to split your data into training and testing. This is what I want to show you. Now let's move back to the mind map. So we are done up to data preparation. Let's see what is there here. So data preparation, you have exploratory data analysis, which you have 4 business moments. And also you have graphical representations. I told you different types of graphical representations like what? Like we have discussed the univariate charts like bar plot, histogram, box plot, density plot. We have seen all these charts, and also we have discussed about the bivariate chart, that is scatter plot. The bivariate chart, that is scatter plot. These are the graphical representations, and you can do these in the results view using visualization section, which we have already seen. And then you have data cleansing or data preparation, in which we have a lot of different steps, just like I've told you, which is duplicates handling and typecasting, discretization, encoding, zero variance, non-zero variance features, missing values. All these things are present under the data cleansing. This is about the next one, that is data preparation. Coming to the most important one, after you're done with cleaning your data, you have to build a model. So for building a model, while we are talking about the model building, you have 2 important terms. One is supervised learning and second one is unsupervised learning. When we are talking about model building, we have 2 words. One is supervised learning and second one is unsupervised learning. So coming to the supervised learning, we have talked about what is what before. In supervised learning, what happens? You have data set or input data. For suppose if you have 10,000 observations, that is your data. That data will go under random sampling. The data will go under random sampling. So after doing the random sampling, we will have training and we will have validation. It is also called as development. So what we do is, we will apply a model on the training data, which we will take mostly as 70%. We will apply the model, whatever the algorithm that we want. And then it will give some accuracy or a mathematical equation. That mathematical equation we will apply on the validation data, which gives us the predicted outcome. So how you are getting the predicted outcome here? By comparing the actual values with the predicted values. That is nothing but accuracy. If you feel like you got very good accuracy, you can apply the math equation on the test data also and check for the accuracy. This is what happens in supervised learning. Then what will happen in unsupervised learning? In unsupervised learning, you don't have this splitting of data, or you don't have this type of predictions. There is nothing like that. So supervised learning is called as predictive modeling. And here you have input variables as well as output variables. But when it comes to unsupervised learning, you don't know the output variable. Output variable is unknown. You know only about the input variable, and this is called as descriptive modeling. So we will talk about the different methods which we have already seen and the operator used in RapidMiner Studio. Okay, the first one that we have is unsupervised learning. The first one that we are about to discuss is unsupervised learning. So in unsupervised learning, you have again a lot of different types. Like what? Like the first one you have is hierarchical clustering. The first one that we have is hierarchical clustering. So what is hierarchical clustering? What do you mean by clustering here? So clustering is nothing but grouping of similar data points together. Why we have to do the clustering? What is the main objective of clustering? So we will do the clustering in order to minimize the dissimilarity present within the cluster. We want to minimize the dissimilarity or the variation. Minimize the variation within the cluster. So we already talked about within the cluster and between the clusters. Always within the cluster, the similarity is more and the distance is less. Between the clusters, the similarity is less and distance will be more. This is what we have discussed. So that is the ultimate goal of cluster. So in which we have different types of clusterings. One is hierarchical clustering, in which you have again two types. The first one is agglomerative clustering. And what is the operator used for this clustering agglomerative? That is agglomerative operator. What is the operator? Agglomerative is the operator in RapidMiner Studio in order to do this clustering. And you also have divisive, which is the reverse of this one. That's it. And apart from the hierarchical clustering, you also have different things. But before moving on to the other topics, we will see what is happening in this particular agglomerative clustering. So here, basically, this is based on a distance matrix. This is based on a distance matrix. Here, we will have different steps. In the step 1, all the clusters or all the individual data points is considered as a single individual cluster. And if you have a single variable, then how to do the clustering process is by using box plot. If you have two variables, how to do the clustering? By using scatter plot. If you have more than two variables, then you have to go for the mechanism called as multivariate distance. And in this multivariate distance, we have again different computations. The first one is we will compute the distance between or distance within the cluster. Within the cluster, we will find the distance between the data points. Second one is distance between two individual clusters. And the third one is distance between a record in one cluster to another cluster. These are the different computations present. Okay, now, what are the distance properties that you have? So distance properties, again, you have different types. What is it? If you have 2 points, I and j, always the distance between 2 points will be greater than 0. The distance traveled between two data points will be always greater than 0. And if you are traveling from one point to the same point, the distance will be always equal to 0. Distance from I to I equal to 0. And distance from I to j is always equals to distance from j to I. And distance have a triangle property, like the sides of two particular points will be always greater than the third point. So these are the things that you have. And the next one is distance matrix for categorical data. We have talked about the variable. If it is continuous, then this is fine. If I have categorical binary data, then what? Then I have different measures like binary Euclidean distance, simple matching coefficient, and also Jacquard's index. We have seen all these things in the previous sessions. You can go through those if you have any doubts. This is about the categorical data. If your output variable or if you have categorical binary data, these are the different techniques present. And if you want to find the distance matrix or distance matrix for mixed data, if your data set is having both categorical and numerical, the mixed data, then you have 3 steps that you can follow. The first one is you first normalize your numerical columns. And then you perform one hot encoding on categorical columns. And the third one is, once you got all zeros and ones, find the Euclidean distance. These are the 3 steps that you have in order to find out the distance matrix when you have mixed data. And you also have Gower's general dissimilarity coefficient. This is the another one present. And also the next one, if you want to find out distance between two clusters, these are all the things that you have when you want to find out distance between records. If you want to find distance between clusters, then what? Then you have linkage functions. So what is the use of linkage functions? Simple linkage complete linkage, average linkage, and centroid linkage. So these are the various ways present, and in this agglomerative clustering, in the parameters in RapidMiner Studio, you can check out these linkage functions are also there. So let me show it to you the operator first, and we will move on to the next type of clustering. So let me go back here, and I will show you the operator that we will use for that particular thing, that is agglomerative clustering operator. And what are the operators there? Here, see. If you see here mixed, Euclidean distance is there. And here if you see linkage functions are there. You can choose whatever you want here. This is about agglomerative clustering. And then what? Apart from this hierarchical clustering, you have the next one, that is non-hierarchical clustering. Under the unsupervised learning, we have discussed a lot, in which one is done, which is agglomerative clustering, which comes under hierarchical clustering. The second one that we have is non-hierarchical clustering. Non-hierarchical clustering. So here, for suppose if you want to create 3 clusters for 25 data points. If you want to create 3 clusters for 25 data points, you will randomly choose the centroids here. In non-hierarchical clustering, what happens? You will randomly choose the centroids here, the 3 centroids, because I want 3 clusters. I will randomly choose 3 centroids, and now I get C1, C2, C3, and we will measure the distance from each centroid to each data point. And we will just continue the clustering process. We will eventually get new centroids. Why? Because which of the distance is less, I will mix that data point into that cluster. So the clusters are going to change. So the distance is going to change. So the centroids are also going to change. This process continues until the clusters does not alter or converge. This is nothing but non-hierarchical clustering, in which we have k-means. And what is the operator that we have for these clustering in RapidMiner Studio? That is k-means clustering operator. Check it out. You have another operator, that is k-means clustering operator. So this is the k-means clustering operator. You can choose the number of clusters and maximum number of runs. Everything else you can remain it as same. This is another type of clustering. And the next one that we have is DB scan. What is the next one? DB scan. It is a density-based clustering. The next one that we have is DB scan. So it has only 2 parameters that we have to mostly concentrate on. What are those 2 parameters? One is EPS, which means radius. And the second one is min PTS, which is minimum points. Based on this, we have 3 different types of points. One is core point. One is border point. And the third one is noise point. So core point is nothing but a point which satisfies or which is having equal to or greater than the minimum number of points. That is the core point. And if you have 2 core points in the same neighborhood, you can just join them as a single cluster. And a border point is nothing but a data point which is having less than minimum points. And it should have 1 core point as neighbor. Then that is a border point. If you have 1 border point, 1 core point near, you can combine them as a cluster. If a data point is not either a core point or a border point, then that is a noise point. This is how you have DB scan. And what is the operator that you have to use in order to perform DB scan? The operator is also named as DB scan only. So see here, this is very easy. So go back here and I want to show you the operator that is DB scan. This is the operator that you have for the next type of clustering, which is density-based clustering. This is the third one. And the next one we have is association rules. The last one under unsupervised. What did we discuss under unsupervised? We have first one agglomerative clustering. Second one is k-means clustering. K-means clustering. Third one is DB scan. And fourth one is association rules. So what is association rules? What is this one? So association rules is nothing but it is talking about the association or relationship between items in a data set. So here You also have a priori algorithm, which is having different types of measures. What are the three different types of measures which you have? One is support, which is used to talk about frequency. And the second one you have is confidence. Confidence captures how independent your antecedent and consequent are. So what is antecedent and what is consequent? Those are the terminologies you have to understand in this association rules unsupervised learning algorithm. What are the terminologies? Antecedent is the part of if part and consequent is else part. So these are the names that you have. And confidence is a measure which talks about how independent antecedent and consequent are. And there is the next one, that is lift ratio. Lift ratio is the ratio between confidence and benchmark confidence. It is the ratio between confidence and benchmark confidence. Confidence talks about how independent antecedent and consequent are. Benchmark confidence talks about how dependent antecedent and consequent are. Along with this, you also have conviction and leverage. And also you have support, confidence. All these things are the measures that you have under association rules. So let's check out what is present in the mind map regarding unsupervised learning. So for association rules, what is the operator that you have? That is create association rules and FP growth. So you have the next one, that is FP growth. It is one operator for association, and also create association rules. These are the operators that you have for association rules unsupervised algorithm. So FP growth is there, in which you can just talk about the support and the number of item sets that you want, and association rules, you can check it out, the confidence and all these things. These we have already seen, and we will see the mind map first. Model building, data preparation is done, and this is also called as data mining or machine learning. You have supervised, we will split the data, and you have training, validation, and testing, which we have discussed, and we will see the algorithms present. Predictive modeling, and you have classification models. Classification models are different types, which I have told you with the help of an example. If a mail is there, if it is spam or not spam, that is binary classification. If it is having multi-class, like in mails, you have promotions, you have social, all these things, that is multi-class. If a mail is belonging to spam as well as promotion, it is multi-label. If it is giving you only the category, that is categorical classification output. If it is giving you the probability as output, that is category probability classification output. These are the classification models present. And coming to the shallow, you have, this is supervised, we will talk it in a bit. Let's say, first of all, unsupervised learning. So unsupervised clustering is there, that is having hierarchical, agglomerative, and divisive. And non-hierarchical K-means is there, K-medians, K-medioids, and K-modes. And density-based, that is DB-scan. And the last one that we have is association rules. These are the things that we have discussed in unsupervised learning. Let's move on to the next one, that is supervised learning. So what is there in supervised learning? In supervised learning, you have again a lot of different types of algorithms, out of which what did we discuss about? We have discussed about naive Bayes. We have discussed about K nearest neighbors. And we have also discussed about decision trees. And we also discussed about regression models. So these are all we have covered under supervised learning in RapidMiner Studio. So what is naive Bayes? What is the first one, naive Bayes? This is a probability-based technique. This is a probability-based technique. So the first one that we have is naive Bayes. This is a probability-based technique. So in this, we have seen what is joint probability, what is conditional probability. We have seen all these things. For suppose if you have emails, out of which 80% belongs to spam and 20% are not spam, and you want to bring in a new event. Now, probability of that particular event, which is maybe lottery, and say 5% of overall emails is about lottery. So how much out of 5% belongs to this one? How much out of 5% belongs to this one? This is called as joint probability. We have also have conditional probability. And what is the operator that we will use for naive Bayes? Naive Bayes is a supervised machine learning algorithm. So in supervised machine learning algorithm, you should split your data into training and testing. For splitting your data, I've shown you different operators. One is cross validation, one is split data, one is split validation. All these things you have in order to split your data into training and testing. So let me show you the operator for naive Bayes. The operator for naive Bayes is same as the name, that is naive Bayes. This is the operator that you have. You can check out the parameters. Laplace, Laplace correction. We have talked about this in the sessions. You can go through those before. And then the next one that we have is k nearest neighbors. The next one that we have is k nearest neighbors. So what is k nearest neighbors? So we change the value of k and we keep on experimenting. This is called as a hyperparameter. And the kind of model which you are not building using any machine learning prediction model is called as a baseline model, which we have already talked about. So baseline model is a model in which you are not using any prediction models, any machine learning prediction algorithms. So when you have an output variable, if it is categorical and if it is having two classes, you will go with majority. And if you have an output variable which is categorical and have more than two classes, then you will go with either majority or with the highest proportion. This is about the k nearest neighbors, which talks about the k value. And what is the operator that you will use for k nearest neighbors in RapidMiner Studio? The operator that we will use is knn. This is the operator that you have. It is also called as lazy learning. So let's check out for those two what is present in the mind map. So here supervised learning is there, out of which shallow machine learning models are there. The first one is naive Bayes, which is probabilistic learning. Here, what is there under this one? So here it works on Bayes' theorem. We have continuous variables, then discreting them will be helpful. And we have Laplace estimator. These are the things that you have. And the k nearest neighbors you have, which is also called as lazy learning. And here we will use the regularization technique. It is also called as a lot of different names: memory-based reasoning, example-based reasoning, instant-based reasoning, case-based reasoning. This is what we have under the k nearest neighbors. And what is the next thing that you have? The next thing that you have is decision trees. So what is the decision tree? What is there in a decision tree? So decision tree is the next type of supervised machine learning algorithm. Decision tree. A decision tree is a tree-like structure in which internal nodes represent test on an attribute and each branch represents outcome of the test. And each leaf node represents a class label. And the path from root node to the leaf node, it represents the classification rules. The path from the root node to the leaf node is called as classification rules. And a decision tree consists of three types of nodes. Three types of nodes. One is root node. Second one is branch node. And third one is leaf node. These are the three nodes that you have. And we have also talked about which node needs to be chosen as a root node depends on various things. The first one out of which you have is entropy. Entropy is nothing but it is the measure of impurity. And also you have the next one, that is information gain. Information gain is nothing but it is based on decrease in entropy after a data set is split on an attribute. Information gain is nothing but expected information, which is entropy, minus information needed. Minus information needed. And what is the operator that we will use for decision trees? That is decision tree itself. But everything that we are about to discuss or that we have discussed before from the naive Bayes, those are supervised machine learning algorithms. So it is mandatory for you to split your data. So the operator for decision trees is decision tree operator. You can check it out. And the next one that we have is regression analysis. The next one that you have is regression analysis. So you have again a lot of different types in this. Before moving on to regression analysis, we have few topics to discuss. One is regression analysis, in which you have linear regression and logistic regression. And in this again, simple and multiple, again simple and multiple, and again ordinal, again multinomial. And again, the last one that we have is neural networks, in which CNN and RNN are there. So we will see all of these things after a quick 10-minute break. So we will have a 10-minute break and we will get back and just talk about the rest of the topics, and we will end our RapidMiner session. Okay, everybody, let's continue with the session. We have stopped at regression analysis. Let's complete the left of the topics and we will end this RapidMiner session. So here, the next one that we have is regression analysis. So regression analysis is nothing but it is one of the other supervised machine learning algorithms that you have. If your output variable is continuous, and if you have single input variable, if your output variable is continuous and if you have a single input variable, then you will go for the type of regression called as simple linear regression. And you also have, we already discussed about the scatter diagram. So here you will also talk about scatter diagram, which talks about the relationship between two continuous variables. Now, so there are primary purposes and secondary purposes like direction, strength, and linearity, and also outliers, clusters, all these things are present, which you already know. And then next, the important thing that you have is ordinary least squares. So we have taken an example of waist, circumference, and adipose tissue for this. When you have data points which are plotted like this, and when you have a line which is predicted line, which is, I will call it as A, I have B over here, and I have C over here. Now, out of all the three lines, the patterns in the data are captured well by which line? Is it A or B or C? So I will say A is the line which captures the patterns very well in the data. How? Why am I telling like that? Because the data points are very closer to A compared with B and C. So I will choose A as my best one. If you have infinite number of lines, then could you decide which line is more chosen? It will be very challenging. For that, people come up with an algorithm called as ordinary least squares algorithm, which is called as OLS. If you don't want to build any prediction models, I already told you we will go for a baseline model. And one more thing is we have already seen SST is equals to SSR and SSE. So this one is, it measures the quality of X as predicted by your predicted value. And this one measures the error in your prediction. And we have also seen the formula for R square. R square is equals to 1 minus error square SSE by SST. This is about the simple thing that you have. And linear regression, what is the operator that you have? That is linear regression, in which you have to choose your output and input variables. You have to split your data and you have to measure the performance using performance regression or performance classification, depending upon your type of output variable. Then you can be sorted based on the accuracy that you get. And the next one that you have is, if your output variable is continuous, and if you have multiple inputs, then you will go for multilinear or multiple linear regression. And then how to calculate regression or how to perform regression analysis for discrete data. When your output variable is categorical, and when you then you need to apply which techniques? That is classifier techniques. And you also have a concept called as binomial distribution. So what is this binomial distribution? It is one of the discrete probability distribution present. For suppose if you have a binomial random variable, that means it is a random variable. It is a variable which tells about the success represented by X in n repeated values or n repetitions. So success, we'll talk about the success in the coming theory. So the probability distribution of this binomial random variable is called as binomial distribution. For suppose you have an event like flipping a coin. So flipping a coin means you will have either heads or tails. That is binomial distribution, binomial experiment. So when I flip the coin for 5 times, then what is the probability that you get only 0 heads or 1 heads or 2 heads? This is called as success. And how many number of combinations you will get? That is NCR, n factorial divided by n minus r factorial into r factorial. If P is the probability of success, then 1 minus P is the probability of failure. And what is the formula for binomial distribution? NCX into P of X into Q of n minus X. P is success and Q is failure. And the next one that you have in regression is logistic regression. The next one you have is logistic regression. This talks about the probability that your output variable is 1. This ranges in between 0 and 1. If the probability of your output variable is equal to 1 is greater than the concept called as cutoff, then we predict the output will be 1. If it is less than or equal to cutoff, then I will just tell the predicted value is 0. In logistic regression, the default cutoff value is 0.5. And we have a formula for probability function, that is P is equals to e power y divided by 1 plus e power y. If you have more than 2 categories, then your value can be either nominal or it can be ordinal. The technique that we are going to apply on nominal data is called as multinomial regression. It is called as multinomial regression. And for ordinal data, the technique that we are going to use is called as ordinal logistic regression. Ordinal logistic regression. And we have again the most important thing, that is line assumptions. So in the line assumptions, L stands for linearity, I stands for independent, N stands for normality, and E stands for equal variance. E stands for equal variance. So we have seen success as well as failure. So odds is nothing but the ratio between success and failure. So we talked about before, this is nothing but P by 1 minus P. P is nothing but success, failure is nothing but 1 minus P. And you already know about the probability function. If we substitute this into this, you will get the log or odds is equals to e power y. If you apply log on both sides, log of odds is equals to log of e power y. This is called as a logic function. These are the main things that we have discussed before. We have also seen confusion matrix, and we have also discussed about sensitivity and specificity and precision, F1 ratio, ROC curve, all these things we have discussed in our previous sessions. And for logistic regression, what is the operator that you are going to use? That is logistic regression operator. That is logistic regression operator. And the last thing that we have discussed in this RapidMiner session is neural networks. The last one is neural networks. So in regression, we have an equation like y is equals to beta naught plus beta 1 into x1 plus beta 2 into x2 and so on. In neural network, you have an equation like y is equals to b plus w1 into x1 plus w2 into x2 and so on. These are all parameters in these formulas. So what are the few applications of deep learning? That is, you have image captioning. It is used to caption the images, and it is useful for deep colorization. Deep colorization is nothing but if you have black images, black and white images, those can be colored with the help of deep learning. And for chatbot, if you give some questions according to the image, it will answer. That is deep learning. And we have also seen compositionality. Like what? First, suppose you have an image, you supply that to your first layer, which is called as input layer, and input layer will be then supplied it to the middle layers, which is called as hidden layers. And the first hidden layer will capture the mid-level features or the low-level features first. If you supply an image of a person, the face of a person, then it will identify under the low-level features like what are the low-level features? So what is nose? What is eye? What are these things that will be understood for this? And ultimately, you will observe the high-level features like the face. and ultimately it will give you the output. And hidden layer, again, it is having two components. One is integration component and the second one is activation component. First one is integration component. Second one is activation component. Suppose if you have 1,000 observations, the moment you pass these observations through your neural network, you will get loss function or cost function. When we aggregate these values, the main objective of our is to minimize the loss. The main important objective of our is to minimize the loss. In order to do this, there is a concept called as back propagation algorithm. Back propagation algorithm is that. Based on this, using this algorithm, I will update my weights. Why I need to update my weights is to reduce the loss or to minimize the loss. This loss function that is getting reduced is using an algorithm called as gradient descent algorithm. The loss function getting reduced is using the algorithm called as gradient descent algorithm. We have three variants in these. The first one is batch gradient descent. Second one is stochastic gradient descent. And the last one is mini batch stochastic gradient descent. You have two concepts in these. One is what is an epoch and what is an iteration. So epoch is nothing but if you pass all the data points through the neural network once, it is considered as one epoch. And what is iteration? Each time you update the weight, it is called as one iteration. For each and every different variant, you have different things like this. For suppose if you have 1,000 observations. For suppose if you have 1,000 observations, then the first one that you have is batch gradient descent, in which for one epoch, you will have one iteration. Why? Because all the data points are passed through the neural network at once, you will get one loss function, one updation will be done. And then you have the second one, that is stochastic gradient descent. For one epoch, it will have 1,000 iterations because individually we will randomly select the observations in this stochastic gradient descent. In mini batch, you have a concept of specifying the batch size. If you specify the batch size as 200, we will have for one epoch 5 iterations because 200 into 5 is 1,000 observations. This is what we have the concept of gradient descent algorithm, which is used to minimize the loss. And the next one that we have is cross entropy. The next one is cross entropy. What is cross entropy? It will give the loss. How far away is your actual value from the predicted value? What is the formula for this? Sigma I is equals to 1 to n pi into log of qi base 2. When you don't have any hidden layer, that is called as perceptron algorithm. When you don't have any hidden layers, that is called as perceptron algorithm. If you have input, output, and hidden, it is called as multi-layered perceptron, which is also called as dense network. All these names are present. And coming to the error surfaces. We have a lot of different things here also. Like if you have a curve like this, our objective is to reach the minima. If you have a curve like this, our objective is to reach the maxima. If you have a curve like this, as we talked about before, when you start updating the weights, your loss gets decreasing. Once it reaches the flat surface, it will stop. But ultimately, I have to reach the minima, the local or the global minima, which is not possible in such type of error surfaces. And the next one is saddle point. When there is a point like saddle point, if you look from one direction, it is observing, I can observe the minima is there. From another direction, I observe it as maxima. That is also one of the challenges that we have. And the next concept is vanishing and exploding gradient. What is vanishing and what is exploding gradient? So vanishing is nothing but if the weights are less than 1, when you keep on multiplying those weights, you will reach ultimately 0. Then your algorithm will stop. If your algorithm stops, you can't reach the minima. That concept is called as vanishing. If your weights are greater than 1, then if you keep on multiplying those weights, you will have very large value. Then you keep on hopping, you don't reach the minima. That is called as exploding gradient. That is called as exploding gradient. And you have constant learning rate. When you use constant learning rate, you will have bouncing around the bottom of the ball problem. In order to overcome this, you can use shrinking learning rate. In shrinking learning rate, we will perform math operations on the learning rate. So this operation that is going to change is called as a decay parameter. For this, again, you have a lot of different techniques like what? Like exponential technique, step exponential, step approach, and so on. And also to avoid overfitting, you have dropout, drop connect, data manipulation, a lot of different techniques you have. And you also have the concept of noise, which you have 3 types: data noise, label noise, and gradient noise. And you have the next one, that is data augmentation. When you have images, it will help you to avoid in 2 ways. One is to avoid overfitting, and the second one is to generate more data, which will be helpful for your model to train, to generate data. And also we have weight initialization, in which again you have Gavier's initialization, which we have seen yesterday. And the next one is convolution neural network. This is used to analyze videos, which is nothing but combination of multiple images. If you have an input image size n and filter size f, and if you are taking stride 1, then what is the formula to find out the output image size? N minus f divided by stride plus 1. And if you are taking padding, then what is the formula? N plus 2p minus f divided by stride plus 1. This is convolutional neural network. And the last one, that is recurrent neural network. Recurrent neural network. Here, this is useful to talk about or to analyze textual data. This is useful to analyze textual data. And here also we have discussed a lot of different things, how it is happening, how the weight you are getting, what is the traditional language models, and to overcome that, how you get this RNN. We have discussed all these things, which marks the end of our session. So these are the various things present, and what is the operator that you can go for this one? That is neural net. That is the name of the operator. So these are the various things present for you, everybody. So you have to understand the theory part, which method you have to go for during which purpose, and understanding that one will give you some knowledge, which is useful for you to drag and drop various operators in RapidMiner tool. And also you can deploy the model which is present in other versions of RapidMiner Studio. You can explore this particular tool, which will be helpful for you in the future. I hope this RapidMiner session is helpful for you. This is the end of RapidMiner session. Thank you, everybody.